Welcome to this e-lecture that will be about research design, how to design a study providing the data we need to answer our research questions. That's what we're going to be talking about in this e-lecture. So first, let's talk about having a cross-sectional design. If you have a cross-sectional design, you really just collect data at a particular point in time. And that is if, as illustrated here, if you have only data on our units of analysis are the international master degree programs at former HIOA, and so those are our units of analysis, and we have only, if we have the numbers of students in 2012, for example, that's data from one point in time, or 2014, that's data from one point in time, and that would be a cross-sectional design. We wouldn't have as in this example, we have data for 12, 13, 14, 15, and 16, but imagine that we only had for 12 or 14 or 13 or 15 or so on. Most surveys that we use, it has a cross-sectional design. We only know or we only get data from one point in time, so we only have a snapshot from one point in time. So then we have a cross-sectional design. If we have a cross-sectional design, we can, or cross-sectional data, we can use a correlation design or a correlation analysis. So we can see whether a high value on one characteristic goes together with a high value on another characteristic. So let's say there's people with high income has a tendency to be more trusting than people with low income. Then it will be a positive correlation between high income and high degree of trust, but it could also be the other way around. It could be that people have a high income because they are not so trusting, so a high value on income goes together with low degrees of trust, so it would be a negative correlation. Or it could be that people with high income, some has high trust, some has low trust, some is in the middle. There is actually no pattern at all, so there is no correlation between the two characteristics, income and trust. And well, this is just one example. We could have there are many more examples of this. So let's look at two other examples. For example, exam results and hours revising. If you use a lot of hours revising for your exam, you will probably get better exam results. So there's a positive correlation between your exam results and hours of revising. And there's also a negative correlation between people with the flu and flu jabs given. So the more flu jabs, the less people with flu. So there is the high value on flu jabs goes together with a low value on number of people with the flu. In this first example, the exam results and hours revising, students are obviously our units of analysis, but in the second one, it could be at the municipality level, for example. We compare different municipalities with and see how many people live there that has the flu and how many flu jab has been given. So it's we have aggregated data for example, for municipalities or communities, for example, and look at the correlation between the number of people with the flu and flu jabs given. But it's important to know that when we have this cross-sectional design and we apply a correlation design, there is always the possibility that we have a potential influence from what we can call confounding variables that can lead to spurious associations. That is association that that seems to be there, but there actually it is not an association. It's spurious because it's this third variable which we may or may not observe that causes the whole association. So how we deal with that is through statistical control for third variables. in order to make units or cases as comparable as possible. And let me illustrate this by giving you an example. If you only look at the two lower boxes here, or the two lower variables, which are the number of fire trucks dispatched and the amount of fire damage. Well, there's a positive correlation between the number of fire trucks dispatched and the amount of fire damage. So if we should take that, make a policy advice of that, we would say that, well, do not dispatch any fire trucks, because the less fire trucks, the less the amount of fire damage. But of course, it's this third variable which is positively correlated with both fire damage and number of fire trucks dispatched, and that's the size of the fire. And I mean, the size of the fire, this is a total spurious association, and we would see that if we control for the size of the fire. So that's making each fire more comparable. We have to see what is the size of the fire, so we don't end up by saying, oh, let's not dispatch any fire trucks, because then there will be no fire damage. That would be a bad advice. Okay, and yeah, if we have a cross-sectional design and we use a correlation design, we use correlation analysis, we cannot, we have no temporal order. We cannot study social processes or development. So we cannot see how things develop, because we don't have the time dimension in our data. And we cannot clarify the temporal order in a causal association. We cannot say that this causes this, A causes B, and so on, because we only have data from one point in time, so we only have one snapshot in time. So making these causal associations are harder, if not impossible, with a cross-sectional design. I would say impossible. But if we have a longitudinal design, we collect data from several points in time. So if it's a longitudinal design, we know, for example, the number of students over the course of many years for different international master degree programs at former HIWA. So then we can see how this develops over time, and we can actually start to see, okay, why did some programs lose students and other gain, for example? What caused that? So with this longitudinal design, where we have data from several points in time, we have some we have some advantages, because we can study a phenomenon and how that phenomenon develop over time. We can study, for example, social processes. For example, the democratization of Eastern Europe. How did that develop? What happened? And what caused different things to or different outcomes to emerge? So we can study effect of changes. If something changes, what happens then? A change on change kind of design. And intervention. If someone intervened, what is the effect of that intervention? We can identify the temporal order, cause and effect in a causal study. So we can say that the cause actually comes before the effect, because it might be that the effect actually is the cause and the cause is the effect, if you understand what I mean. It's really, we have to basically, if you're going to make a causal statement, you have to know the temporal order of things as a minimum. And if we have a longitudinal design, we have also disadvantages that we can separate between competing explanations on differences between age group, for example. Is this a life course effect, or is it a generation effect? And in the first one, graph, you can see how different generations use different amounts of dairy products, or how much money they spend on dairy products. So that's probably a generation effect. The older generation use more more dairy products, or it might be that it actually changes over time. So it's like as you grow older, you use more dairy products. From this graph, we actually don't know, because it's actually a cross-sectional data. But in the second, in the other graph, it's based on register data, and it's longitudinal in the sense that we can see how income develops over time for people with either a high school as their highest educational attainment, or college or university as their highest educational attainment. And as what we can see here is that, of course, that as people grow older, their income also their earnings also go up. but what we also see is that people with high school as their highest educational attainment they have on average that they earn more, or they earn more in a time span between 17 and 27, but after that people with college or university they earn more. And the straight lines are the average income in both groups, and over the total life course, of course, people with the college or university education earn more. But it's actually a life course effect, and the difference increases over the life course between these two groups on average. So we can also have a trend design, or a repeated cross-sectional design, where we just take a new sample and ask at different points in time. We can send out a survey, for example, but we send it to new samples each time. So it's not a longitudinal design, it's a trend design in the sense that we don't ask the same people. So it's a what we call also a repeated cross-sectional design. And then you have the panel or prospective design, where you where you, for example, start at T1 at one point in time, and then you follow the same people for one more time, and you ask them at the T2. So you have a start and an end point in time. The problem with asking people, for example, 2 times or 3 times, is that it takes time. It's expensive. You lose people. Some will not join you at T2. They will be with you at T1, but then they fall off between T1 and T2. And you have response, so people will maybe join you at T2, but they will not respond to some questions, for example, attrition can also be that people actually they move, for example, but and so attrition and non-response is really the same in a sense that non-response is more that you choose not to respond. And subject fatigue, people get tired by being asked the same things over and over again. But you can also have a retrospective longitudinal design, where everything starts at time 2 as starts and end. But so you ask people, what did you do at time 1? What did you do? So you can kind of get this longitudinal or get information about what happened over the course of several time points in time, by asking people what they remember. But the problem is also, of course, memory, because people tend to forget, and people tend to have a selective mind. So selective memory is a huge problem, of course. So yeah. Comparing trend design to a panel design, of course, and a trend design is then you just ask different you ask different samples of people the same questions over time, whereas a panel design you follow the same people over time. The advantages of a trend design is that you can look at gross change. You can reveal changes for a social group over time. For example, you can look at how confidence among 20 to 25-year-olds changed in Norway over time. What is the gross change? Are they more or less confident? Furthermore, it's less expensive, and you have less you don't have attrition, because it's different people each time, so you get a high response rate, and you have no subject fatigue because it's different people each time that you ask. The disadvantage is that you cannot look at net change. You have no net changes because you cannot reveal changes for one individual or for individuals over time, because we study different individuals each time. So you cannot look at net change. You can only get the gross change. So the panel design, of course, the advantages is that you get gross change. You can reveal changes for social groups over time, but you can also reveal changes for individuals over time because you ask the same individuals. And the disadvantages is that it's expensive. You have attrition, people fall out, which causes low response rate, and then subject fatigue. People get tired by being asked the same questions all over again. Yes. And then we have what we call the experiment, which is also a way of designing your study. In an experiment, you have a population, and from that population, you draw a probability sample, or and this sample of units, and that's to secure generalize or the possibility to generalize back to the population, say that this is representative of the population as such. So this sample of units is a good mirror of the population. So we can use this sample of units to say something general about the population, and then we secure that by having a probability sample. And so then we take this sample of units and we randomly assign them to the experimental group and the control group, and that establish non-spuriousness. So we know that there is no third variable, or at least this random assignment is going to give us solid. Then we have a solid argument that there is nothing third variable that we do not observe, and that is different from the experimental group and the control group. We know that they are the same. They are equal on all important third variables, and you secure that by making a random assignment. And then you can do a pretest to further establish that argument by asking the experimental group and the control group, for example, how depending on what your experiment is all about, you can ask them about different opinions and so on and so on, and then see that, and hopefully you will get the same answers in both groups, or there are no significant deviations between the two groups before you do the treatment or the manipulation. For example, and when you do that, you treat the experimental group. You do something to them, so they're different from the control group. So you establish the temporal order. So you know that at that point they got the treatment, and then you do a post-test. You ask them, the experimental group and the control group, and see if this treatment provided any effect, and then you establish the association. You see whether is there a difference between the experimental group and the control group after the treatment. And let me give you an example of an experiment. Here you have an example which is computer games and aggression. Well, basically these researchers, they were wondering whether there was a possible sex difference between I mean, a difference between girls and boys, and if they were unequal affected by playing violent video games. So they took a participant 18 to 23-year-old undergraduate students, make them which had played both Mortal Kombat and Tournament Golf before. Mortal Kombat is the violent game, Tournament Golf is a non-violent game. And they took the boys and the girls and they put them into an experimental group and a control group. An experimental group was treated with playing Mortal Kombat, whereas the control group played Tournament Golf. So I mean, this is the only difference between the two groups. They played different video games. And then afterwards, they made them play another game where they could punish the competitor if the competitor lost, and they made a score on the intensity of the punishment. So I mean, this is really to test whether you're an aggressive, whether you want to show aggression or not aggression in this second game. And what they found, as you can see here, that there is the intensity of the punishment in the second game after playing this violent video game or not violent video game, there is no significant difference for the girls. The intensity was fine 5.05 for the experimental group among the girls and 4.61 among the control group. So there's really no difference. But there is a huge difference between the boys. The boys who played the violent video game had a much higher average intensity in the punishment in the second game after playing Mortal Kombat than those who played Tournament Golf. So this article provides some evidence for the fact that there might be a sex difference in aggressive behavior after playing violent video games. Okay, so true experience versus quasi-experiments. In a true experiment, we have two or more comparison groups to establish an association. We have the experimental group and the control group, and we have manipulation of the independent variable to establish time order. And we have a random assignment to the comparison groups or group to establish non-spuriousness. Whereas in a quasi-experiment, we may have both experiment and a control group, or only an experiment group, and the manipulation of the independent variable also establish the time order, but we do not have this random assignment to the comparison groups to establish non-spuriousness. So the problem with the quasi-experiment is that we do not have the same control of third variables, or we do not have the same control that these two groups, the control group and the experiment group, are actually the only difference between the two are the treatment or the experiment. We don't have that same control, but we have arguments. We can argue for having that control, but the experiment, the true experiment, is very much more robust than the quasi-experiment. Okay, that was the e-lecture on research design. Thank you so much.